Introduction. What if one book could change the way you think? Today we are diving into AI-first healthcare, and by the end of this video you will have its biggest ideas in just a few minutes. Here's what is coming up: a quick overall summary, then a section-by-section breakdown of the most important points. Overall summary. Machine learning and neural networks. There are different types or subcategories of machine learning, such as supervised learning, unsupervised learning, and deep learning. AI healthcare myths. There is so much excitement involving AI in healthcare, but what exactly is AI in healthcare supposed to fix? AI use in healthcare should be to extend provider capabilities, ease patient access to and use of healthcare, and so on. AI may be the only way to provide access to best-in-class healthcare to millions of people who don't have access to healthcare services or can't afford healthcare services. Chapter 1: Learning and Data. That said, thoughtful AI use in healthcare creates an enormous opportunity to help people live healthier lives and, in doing so, control some healthcare costs and drive better outcomes. Real-world data is different. That is, the training data does not match the real-world data, and this causes a data shift. This situation persists today. AI in healthcare is not readily found at the clinical bedside. For example, deep learning algorithms outperform radiologists at spotting malignant tumors. Will these machine learning diagnostic tools meet the same fate as the expert systems of the 20th century? This is not the 1970s. AI now permeates healthcare in a variety of ways in production. For example, machine learning helps with steering patients to the optimal providers. This book on AI-first healthcare hopes to show a different future for the widespread adoption of AI in healthcare, including in clinical settings and in people's homes. If we think of AI solely in the context of ML, it's doubtful that we ever build intelligent systems that mirror human intelligence in the performance of clinical or healthcare activities, or that we create AI that materially enhances patient experiences, reduces costs, and improves the health of people and the quality of life for healthcare workers. Furthermore, the most common AI applications utilizing deep learning, computer vision, or natural language processing all employ machine learning. The supposition that machine learning is the same as AI ignores or dismisses those aspects of a software stack used to build intelligent systems that are not machine learning. We expect and need the many AI capabilities for engineering healthcare solutions illustrated in Figure 1.1. Transforming healthcare with AI involves computer vision, language, audio, reasoning, and planning functions. There are different types or subcategories of machine learning, such as supervised learning, unsupervised learning, and deep learning. In supervised learning, we train the computer using data that is labeled. A supervised machine learning algorithm learns from labeled training data. With supervised machine learning, we effectively use a computer to identify, sort, and categorize things. Much of the learning we do as humans is unsupervised, without the benefit of a teacher. We don't give the answers to unsupervised learning models, and they don't use labeled data. Unsupervised machine learning recognizes the unique features of the child's mother. Learning from the data, it identifies the mother in images with high accuracy. Deep learning uses a series of algorithms to derive answers. Data is split into training and test data, using training data to build a model and test data to validate the model. In this email example, we labeled data, which is supervised learning. Chapter 2: Learning and Healthcare. Often machine learning facilitates the identification and classification of objects. Solving many healthcare problems requires AI to realize a planning component. Planning and machine learning operate complementarily to solve challenging problems. It uses machine learning and techniques such as computational algorithms, aka Monte Carlo, to determine its next move. Another aspect of planning addresses the black box challenge of deep learning. Machine learning performs many human tasks better than humans, but not reasoning. But a computer using deep learning would not be able to understand implicit relationships between different things, something humans do quite well. Healthcare solutions that need reasoning will consider both old and new AI techniques as well as emerging research. In healthcare, people filing claims would like instantaneous affirmative responses. AI in healthcare must do no harm and in many cases should be held to a higher standard of care than AI in vehicles. Engineering autonomy in healthcare solutions must be a human-centered process. AI cannot operate in a vacuum. People are needed to curate and provide data, check for biases in data, maintain machine learning models, and manage the overall efficacy of AI systems in healthcare. 5 highlights key innovations that became transitions for powering new AI applications and solutions in healthcare and other industries. At the time, we thought this was a sign of artificial intelligence catching up to human intelligence. Machine learning techniques and predictive analytics were born, and the second AI transition was underway. Deep learning, new algorithms, GPUs, and massive amounts of data are key differences. The demonstration of neural nets, deep learning algorithms, and the reaching of human perception in sight, sound, and language understanding set in motion a tsunami of AI research and development in academia and technology companies. AlphaGo uses deep learning and is another iconic display of AI. The limitations of deep learning and AI are well known to researchers, bloggers, and a number of experts. Point 6 For example, deep learning cannot itself explain how it derived its answers. It's narrow because, for example, we train machine learning models to detect pneumonia, but the same model cannot detect tumorous cancers in an X-ray. Deep learning most likely will get a makeover with new research and innovations. Today AI and humans must work hand in hand to solve problems. AI can go wrong, and we need clinicians with intuition and experience doing healthcare augmented with AI. Chapter 3: Healthcare and Disease. Intelligence and learning are complicated. There is no miraculous AI fix. We cannot wave a magic AI wand that will fix healthcare or make people healthier. But we can still use machine learning rather than handcrafting for many of today's problems, allowing us to future-proof systems using machine learning as they learn with new data and to avoid programmers writing more code. Understanding and exploring AI healthcare and technology myths illuminates our understanding and definition of AI. Next, we'll turn our attention to discussing some key myths in AI healthcare. There is so much excitement involving AI in healthcare, but what exactly is AI in healthcare supposed to fix? People look to AI to predict future disease, prevent disease, enhance disease treatment, overcome obstacles to healthcare access, solve the burden of overworked and burnt-out clinicians, and improve the health of people overall while decreasing the cost of healthcare. While some of this is achievable, AI is not a miracle panacea for all health and healthcare-related problems. AI in healthcare must be applied for the right purpose, with review of potential risks in the forefront of developers' minds. One of the major myths regarding AI is that AI will replace physicians and other healthcare providers. The transformation from raw data to insights to intelligence is a process that is guided by clinicians working with data scientists using AI. The clinical interpretation of data is dependent on humans and their understanding of disease processes and its effect on the timeline of progression of disease that molds this early knowledge. Algorithms for disease management, identification of risk factors predicting the probability of development of disease. These are based on human understanding and interpretation of the disease process and the human state. Insufficient on-demand healthcare services. AI is already addressing some of these needs with applications like Lark Health, which manages using smart devices and AI with deep machine learning to manage well, at-risk, and stable chronic disease patients outside of the healthcare system. AI incorporation into healthcare payer systems is prevalent today. Again, the judicious application of AI to healthcare gaps is needed. AI is used in an inconspicuous manner in healthcare for the most part, due to patient and provider skepticism and resistance to change. These are just a handful of examples of AI use in healthcare today. The healthcare industry seeks to address high-cost healthcare situations that impact patients' health. An initial step is to gather as much data as possible for machine learning to occur. AI will not replace healthcare providers, but it is a powerful tool for augmenting physicians' work in identifying and managing disease. AI is not a replacement for a medicinal cure that may one day end diseases, e.g., coronary artery disease and cancer. However, advances in AI, the massive accumulation of data, i.e., big data, and data sharing in healthcare could lead to what does end diseases. Of course, helping people avoid getting a disease is not the same as curing the disease. Chapter 4: Healthcare and Cancer. The norm today is that we work to prevent disease, often with the use of machine learning. Routinely, healthcare companies take in data from electronic health records, EHRs, healthcare claims, prescriptions, biometrics, and numerous other data sources to create models for the identification of at-risk patients. For prevention to be effective, healthcare constituents need to use artificial intelligence to support decisions and make recommendations based on the assessment and findings of clinicians providing healthcare to all patients. The healthcare ecosystem comprises consumers in need of healthcare services, clinicians and providers who deliver healthcare services, the government, which regulates healthcare, insurance companies and other payers that pay for services, and the various agencies that administer and coordinate services. We will examine this in greater detail in Chapter 3, in which the world of intelligent machines and ambient computing and its impact on healthcare is discussed. The volume of data streams makes this unmanageable for a human but highly possible for intelligent machines supported by AI. By identifying and stratifying individuals most at risk, AI can alert physicians and healthcare companies to intervene and address modifiable risk factors to prevent disease. Embedding AI technology in cancer treatment accelerates the speed of diagnostics, leading to improved clinical decision-making, which in turn improves cancer patient outcomes. Another study applied AI to the prediction of cancer cell response to treatment. Identifying and diagnosing cancer in its early stages, coupled with proper care treatment, increases the opportunity to cure patients of cancer. AI can significantly contribute to the diagnosis of patients based on signals or symptoms missed by human detection. Gathering data from large population pools allows an understanding and awareness of the most effective plans for treatment. This is where AI, specifically deep learning algorithms using large datasets containing the data of millions of patients diagnosed with cancer all over the world, could play a major role. All of which leads to worldwide health data aggregates being a thing of the future. Human error that results in a delay in diagnosis, or a misdiagnosis, can be a matter of life or death for cancer patients. Detecting cancer early makes all the difference. With the data available in relation to cancer and its treatment, AI has the potential to assist in creating structure out of these databases and pulling relevant information to guide patient decision-making and treatment in the near future. Tools that rapidly analyze large amounts of patient data to provide signals that may otherwise go undetected should increasingly play a role in healthcare, as should machine learning algorithms that can learn about a patient continuously. In Chapter 3, we explore the synergy between increasingly instrumented patients, doctors, and clinical care. Despite the plethora of seemingly almost daily news stories about new machine learning algorithms or new devices or AI products improving healthcare, AI alone will not fix the healthcare problems confronting societies. There are many challenges that need to be solved to make our healthcare system work better, and AI will help. But let us dispel the next myth about AI alone fixing the problems facing healthcare. Dnode saw a healthcare future driven by entrepreneurs, not by medical professionals. Doctors can make a human connection, which may directly influence how a patient feels and can facilitate a patient adhering to a treatment plan. AI cannot yet converse with patients in the manner that a human doctor can. Chapter 5: Healthcare and Access. A doctor's ability to navigate the healthcare system and pull together this disparate data is critical to patient care. Most assuredly, AI fixing the myriad of healthcare problems is a myth. In the United States, the current healthcare system has a large ecosystem of providers, insurer systems, payers, and government agencies who must play well together to increase access to healthcare, reduce costs, reduce waste, and improve care. Generally, when governments discuss the healthcare problem, they are referring mainly to our nation's exponentially increasing expenditures on healthcare. The ability of AI to overcome obstacles to healthcare access, solve the burden of overworked and burnt-out clinicians, and improve the health of people while decreasing the cost of healthcare is possible but exaggerated. Administrative costs are adding additional burden to the healthcare system, along with the rise in healthcare costs as medical advances lead to prolonged longevity and the associated costs of an aging population. Neither technology nor AI can fix all of these problems, so realistically, the question is, how can AI help address some of the healthcare issues? First is the issue of access, as access to healthcare is composed of three parts: gaining entry into the care system, usually through insurers, having access to a location where healthcare is provided, i.e., geographic availability, having access to a healthcare provider, limited number of providers. The Patient Protection and Affordable Care Act, ACA, of 2010 led to an additional 20 million adults gaining health insurance coverage. This gap is so relevant as a major healthcare problem because the evidence shows that people without insurance are sicker and die younger, burdening the healthcare system and contributing to higher government costs. The American Medical Association, AMA, has endorsed the ACA and is committed to expanding healthcare coverage and the protection of people from potential insurance industry abuse, which increases access to healthcare and thus increases the likelihood of people living healthier lives, thereby reducing the costs of healthcare. Although AI alone cannot fix all healthcare problems, it can play an enormous role in helping to fix some issues in healthcare, a major one being access to healthcare services. While governments work on addressing insurance coverage reform, AI is gaining a foothold in increasing healthcare accessibility. China provides an illuminating case study for how AI can help to reform healthcare access. China is facing arguably the largest healthcare challenges in the world. So China has relied heavily on AI to address its healthcare issues. There are several prime applications for AI, including clinical decision support, patient monitoring and guidance, remote or direct patient management, surgical assistance with automated devices, and healthcare systems management. All components of healthcare are projected to increase at exceedingly high annual rates over the next decade. The myth regarding AI and healthcare costs is the thinking that AI will completely reinvent or overturn the existing healthcare or medical models in practice today, or that AI use alone will be able to contain healthcare costs. Tremendous evidence abounds that the big technology companies and startups will transform how healthcare is done. AI using machine learning and deep learning has been adopted by various groups to develop automated DR detection algorithms, some of which are commercially available. As an example of how treatment management can impact healthcare spend, let's examine low back pain. Hospitalization and administrative costs are also a major driver for U.S. healthcare. Another area of high healthcare spend is medication research and discovery. Closing. That brings us to the end of our review of AI-first healthcare. Thank you for listening. If you found this helpful and would like more book summaries like this, please subscribe to the channel and turn on notifications so you never miss a new video. Tell me in the comments which book I should review next, and I will see you in the next one.